Our next speaker is Jen Lawson, who's our water quality manager for the city. Jen's in our systems planning group. For those of you that don't know, systems planning is a redesigned part as the city reorganized that tries to bring some of the core infrastructure expertise all together in one place. So water, wastewater, GIS, infrastructure modeling, energy, environment, capital improvements, and I've missed composting, recycling, and a bunch of others. But with that, I'll introduce Jen, and she'll talk to you about stormwater. Thank you.
Thank you, Matt. I'd also like to make another introduction here for moral support, but also our unit director from systems planning is Crescent Slot, and he'll be joining us on the panel as well. Well, we just heard from Rick. Make sure I have these correct. Okay. We just heard from Rick about the city's responses to emergency management, and I'd like to delve in a little bit deeper and really talk about some of that infrastructure that the city owns, operates, and maintains at the benefit to the community, most specifically stormwater. So to familiarize yourself, this is a map of the city. North is up. The red lines are the freeways, the green lines are our major corridors in the city. But this is how I look at it. All of those green lines are the stormwater main network. The blue lines are open water. Keep in mind that those are only the city-owned pipes, not privately owned, no private development, not university-owned, not county-owned, not open water, state of Michigan. It's a lot of pipes. In fact, it's 231 miles of pipes. One of the things we deal with, though, when we start thinking of how to manage these pipes, or how are these pipes sized, installed, and what's the best technology for some of this management techniques. When were they put in? Almost 20% of our pipes were installed before D-Day. Think about that for a minute. How many of you were even a gleam in someone's eye at that point? 75% of those pipes were put in over 30 years ago. Some of you, again, were still not a gleam in anyone's eye at that point. Then we do have another 25% of our storm pipe that's much more recently installed. We have a small amount, you'll notice about just less than 5% that we have is unknown. That's because we don't have as-builts, or we really don't know when it was installed. Now keep in mind, those are only those city-owned pipes. We can almost double that. We have 541 miles of stormwater conveyance in the city that is publicly owned. And by publicly owned, I mean university, state of Michigan, county, or the city. That's open water also, so ditches and river channels as well, but that's 541 miles of pipe. So for reference, 231 miles of just the city-owned pipe, that'll get us almost to Chicago. 541 miles of pipe gets us to St. Louis. That's a lot of pipe to manage, inspect, and make sure it's functioning properly. One of the questions I always get is, oh God, those pipes are kind of old, aren't they? Why were they put where they were? And one of the familiar terms, and for some of you in the room, may be Allen Creek. This is a map of the city that was before 1920. I don't have an exact date, but I do know it was before 1920 because those blue lines are actually where Allen Creek used to be. And you can see that there are several fingers going right through downtown. For reference, I have Main Street, Miller, and Huron. Many of you may walk along these streets and notice, oh, there's a dip in the road. Probably because that's where the creek used to be. Anytime you look at a storm drain anywhere downtown, it's going into what used to be Allen Creek. And we, typical of any sort of developing urban community, we put the creek in a pipe. Now keep in mind that creek still functions like a creek even though it's in a pipe. When it rains too much, creeks overflow. What do you think happens to the pipe? When it rains too much, the pipe can't hold all of that rainwater, and so it does tend to overflow just like any natural creek would. This is one of my favorite photos. This is what Allen Creek used to look like. This is looking north at Washington Street. Those two houses on either side are still there. So the gentlemen are standing on Washington Street. Now, when we put Allen Creek in a pipe, we didn't make a really big pipe at that point in time. We looked to see what fit. We literally went out, and then there are some of these timbers still in existence. What pipe fits underneath that already existing bridge in 1920, and let's fit the two ends together. And that is a lot of the system that we still are dealing with today. It's pre-1920s hydraulic design. Taking a step outside of the pipe, one of the things that we also have to kind of think about managing or think about what some of those impacts are to how the water gets into the pipe is impervious areas, impervious issues. Impervious, I have a nice Merriam-Webster definition up here, not allowing something to go through. So when it rains, if the ground surface is impervious, it runs off. It goes into the street, it goes into the catch basin, it goes into the river. It doesn't soak back into the ground like it did before this area was developed and settled. If you think about Allen Creek, and I'm going to refer to Allen Creek a few times just because it's really that downtown area that everyone's familiar with. Allen Creek is 50% impervious. So for every 2 raindrops that fall on that land area in Allen Creek, whether it falls out at Pioneer High, at the stadium, by downtown Home and Garden, or over by Argo Dam, for every 2 raindrops that fall, one of them goes right into our storm drain pipe. It's a lot of water for those storm drain pipes to handle. Another issue that we deal with stormwater management is flooding. Everyone's heard of the 100-year flood, right? It only happens once every 100 years. Not true. Science has indicated to us, as well as our own experience, that a 100-year flood really isn't the best terminology. It's not the best nomenclature for us to use. And so NOAA and FEMA as well have agreed on what they're calling a new term, or a better term to use. And it's not the 100-year flood, it's the 1% chance storm. So in any given year, it has about a 1% chance of occurring. That doesn't mean that it won't occur every year. In fact, it's occurred at least once to my knowledge in this area. But taking that same science, a 10-year storm, which is what our pipes are designed for, a 10-year storm has a 10% chance of happening in any given year. And I'll talk about that a little bit because those are some of the numbers and the hydrology behind how do we design storm pipes, how big are they, what size are they, where should we put them to manage what's coming in off of those impervious areas that we're developing. So a little bit of history about the city's stormwater management system from a sizing perspective. Storm drains are not designed to pass every single storm that happens. It's impossible. We cannot build a system that's large enough to handle that. In fact, prior to 1980, the storm size varied. Not because it was what pipes were available, but it's different technologies, new technologies. Every year there was a better and more accurate design. So since 1980 until now, we designed for the 10% annual chance storm, which again, in the old terminology, is a 10-year event. One of the questions we get often is, why can't you just build a bigger pipe? I don't understand, just build a bigger pipe, just do that. In 1998, the city worked with an engineering consultant to evaluate just Allen Creek, again, in that downtown area all the way up to Pioneer High area, just to build bigger pipes to design or to handle the city's current design standards, which at that time was, again, the 10-year event. That's not to prevent flooding, that's not for water quality, that's just that 10% chance storm. And in 1998, it was $41 million, and it would have torn up pretty much all of downtown. In 2012 dollars, that's $61 million just in a small area of the city. So when storms do occur, they do surcharge into low-lying areas. The streets, in fact, are part of the conveyance system to handle stormwater. Our stormwater inlets, so the grates that you see in the street, they actually are only designed to handle a 2 cubic feet per second capacity. And that's assuming that there aren't leaves blocking, there aren't solo cups blocking them, and every cigarette butt and all of the debris that's there. For reference, this is a pipe that was installed last summer on Stadium Bridges project. This was designed for that 10% annual chance storm, as well as what we refer to as the bank full rain event. And so if this were still a creek, the water would rise to the top of the banks. And you see the gentleman down there in the yellow shirt jacket? He's standing in a culvert that is 5 feet tall by 9 feet wide. And the access hole on the top is 9 feet wide, so we can get a Vactor truck down in the pipe to Vactor out any debris that ends up down in there. So I've talked a little bit about quantity. There are also regulations the city has to follow for quality. And really briefly, we had no federal regulation prior to 1970. The Clean Water Act happened in 1970. In 1990, the Clean Water Act was reauthorized, taking it from point source to non-point source discharge. Currently, we encourage low-impact development, which takes the water more at the source. And so how do we keep the water where it falls rather than pushing it to someone else and making it someone else's problem? In line with those stormwater regulations we have to deal with from the federal level, we also have state, local, and even county multiple varying regulations that we have to address. It gets a little bit messy sometimes, guys. So what happens when we get these extreme weather events? This was March 15th. This was the Dexter tornado. Looking at Depot Street, taken about 6 p.m., so just after the tornado kind of hit in Dexter. And you can see the streets are flooded. They're absolutely flooded. The stormwater surcharged out of Allen Creek and entered into our streets. So what's the city doing? What can we do about this? I've kind of told you the story of what are the pipes that we have. There are limitations to the system, and we know those limitations from a physical standpoint. The city is currently calibrating our stormwater model for a more exact understanding of how the system functions in these varying rain events, including that March 15th event. How should our system function, and where will the water surcharge out? We also, again, as I mentioned, work with low-impact development. We try to deal with stormwater at the source, not only with developers, but also using as a resource to the public, and we'll hear about that from Jason Frenzel in a moment, but really looking to our homeowners and our property owners. There's also some sort of responsibility and understanding of how stormwater does function. And I want to close with one question by show of hands. You guys have all seen storm drains in the road? How many of you guys know where they drain to? How many of you think you know where that pipe leads to? How many of you would believe me if I said every single storm drain in the entire city of Ann Arbor goes to the Huron River? That's a true statement. We do not treat anything stormwater-wise. Every cup of coffee you dump out goes to the Huron River. Every cigarette butt that you flick out goes to the Huron River. So there is certainly a connection that I think every single one of us walking on the way here, even from the parking lot, probably saw that connection. And with that, thank you.